All right, good morning, everybody. Today we're going to finish up our notes on 5.1, dealing with logs. All right, we did some review of like graphing, natural logs, properties of logs, expanding, condensing, and then we did the derivatives, which of a natural log, which is du over u. And this formula can be found on your formula sheet, which you are allowed to use. Okay, so really short today. All right. Two things we're going to talk about: logarithmic differentiation and implicit differentiation. Okay. So logarithmic differentiation is used for taking the derivative of a complicated looking functions that do not already have a natural log in the equation. Okay. So if I were to look at this and say, all right, find the derivative, you'd probably be like, all right, we'll probably have to do some sort of quotient rule. But the problem is when you divide by use the quotient rule, the derivative top and bottom, you'd have to use the chain rule on top. I got a square root and a fraction. It's going to be a pain in the butt. All right. So if you see something and on a quiz and on a practice homework, it will say use logarithmic differentiation. And what we're going to do, first step here, is to take the natural log of both sides. All right. So you're just going to take the natural log of this side, the natural log of that side. All right. Now, we then are going to expand it. All right, we are then going to expand. There's nothing you can do with the natural log of y, so it's just the natural log of y equals. All right, now this is what we're going to expand. Remember, anything on top gets a positive, anything at the bottom gets a negative. Exponents move out front. So this is going to become 2 natural log of x minus 2 minus, because it's now going to be the bottom, 1/2 natural log of x squared plus 1. Why is it 1/2 in the front? Because remember, square root is x squared plus 1, so 1/2. The fraction comes out front. All right, so that's expanding. All right, now we're going to take the derivative. So now we're going to take the derivative of natural log of y. We're going to take the derivative of this. And we're going to take the derivative of this, of what we've learned last time, which the derivative of a natural log is du over u, which is the derivative of the inside over the inside. So the derivative of y is 1, all right, over y. But since I'm doing it, this is all with respect to x. So if we're doing with y, what do I put after it? Put a dy over a dx, which is going to be our derivative that we're going to solve for. So it's 1 over y, dy over dx. So when you do a logarithmic differentiation problem with y equals like this is what you always get on the left-hand side. All right, 1 over y, dy dx. So now I get 2 times the derivative of x minus 2, which is just 1, because the derivative of x is 1, 2 is 0, over x minus 2 equals, minus, it's not equals, minus 1/2 times the derivative of x squared plus 1, which is 2x, over the inside, which is x squared plus 1. All right. So to clean this up a little bit, all right, what we are going to have is, we're going to have 1 over y dy dx equals 2 over x minus 2 minus, these 2's are going to cancel. It's going to give me x over x squared plus 1. Okay. All right, so now what it says to solve for dy over dx. So I need to get this by itself. So what do I have to do in order to get rid of this 1 over y? Well, I'm going to multiply by y. That's going to cancel that out. All right. So I have dy over dx equals 2 over x minus 2 minus x over x squared plus 1 times y. And then the final answer is to plug back in for y. Now listen, you do not need to go and actually rewrite it. This is what is y? Y is this. This is what y is. X minus 2 squared over x. So we're just going to substitute. It's actually, I probably shouldn't circle that part of it. This is what y is equal to. This just gets plugged back into there, and that is your answer. So the derivative is this parentheses times that. like I said, you literally for your final answer can circle what the y is and show you plugging it back in for y, and I'm completely fine with that. All right, instead of rewriting all of it again. All right, so it's this times that. That's your answer. All right, and you can just leave like that. Don't do anything else. All right, so let's try number 2. So we're going to take the natural log of both sides and expand it. So it's going to be the natural log of y equals, all right, so we got to expand this. So we have 1, 2, 3 different terms. So we're going to have 3 logs. All the exponents go in front. So natural log, 2 natural log of x plus, because it's on top, anything that's on top gets positive, anything at the bottom gets a negative. 4, because that's your exponent, natural log of 5x plus 3. Minus, because it's on the bottom, 1/2 because it's a square root, natural log of x squared plus 1. All right. So now we take the derivative of each. All right. They're going to get the same thing we did for natural log of y. The derivative of y is 1 over y, but it's a dy over dx. All right. 2 times the derivative of x is just 1 over x. So 2 times 1 over x plus 4 times the derivative of 5x plus 3 is 5 over 5x plus 3 minus 1/2 times the derivative of the inside, which in this case is 2x, over x squared plus 1. All right, so we're just going to, kind of like we did before, just clean this up a little bit. We're going to get 1 over y dy over dx equals 2 over x. All right, plus 4 times 5 is 20 over 5x plus 3. You cannot cancel out those 5s, by the way. Minus, once again, same thing as the other problem, these 2's cancel, and it's x over x squared plus 1. We are going to multiply both sides by y. This cancels, so we're going to multiply all of that by y. We are going to take this and plug back in, because that's what y is. And that goes right there, and that's your answer. 2 over x plus 20 over 5x plus 3 minus x over x squared plus 1 times all of this. That's your derivative. All right, so that is logarithmic differentiation. All right. You take the natural log of both sides, you expand it, you then take the derivative, then you solve for y and plug, circle y, draw an arrow to y, and there you go. That's you plugging it back in. All right. So last thing we're going to talk about is implicit differentiation, which we've actually already have done. All right, before. It's just now we're doing it with natural logs. So implicit is when the ones that are going to solve for y. So this is where any place you see a y, we put a dy dx, and then we have to solve it back. So even says here, we did this back in section 2.5. All right, so we're going to take the derivative of each term and then solve for dy dx. So x cubed is just obviously 3x squared. 2 natural log of y is 2 times natural log, the derivative of y is 1 over y. But since I'm doing y, I have to do dy dx plus the derivative of y cubed is 3y squared. But since it's a y, I got to do dy dx equals the derivative of 8, which is just 0. All right. So this is where you get all the terms that have a dy dx, if you have multiple ones, on one side. Everything else goes on the other, and you're going to factor out a dy dx. So this goes over there, so it's going to be a negative 3x squared. So I'd be left with 2 over y dy dx plus 3y squared dy dx. Well, I need to solve for dy dx, so I put that on the, I'm going to factor it out. That's the only way we do it. And they get 2 over y plus 3y squared. And then my final thing would be to divide by this, all right, to solve for dy over dx. All right, so negative 3x squared over 2 over y plus 3y squared. All right, now, just notice something as I'm doing this problem, like, final answer, what's wrong with this? All right, well, what's wrong with this is we have a complex fraction, okay? So we have to get rid of this y, all right? We got to get rid of the y. And what we can do is we can multiply everything here by y. Why? Because this is the denominator. And you get negative 3x squared y over 2 plus 3y cubed. And there's your final answer. Now, what you can do so that you don't have to do, and I'll show you this in this example number 2, is that once you get to this step here, what we could have done is I could have multiplied to clear out the fraction. I could have multiplied everything by y. And I would have got 3x squared y plus 2 dy dx, right? Because this y is going to cancel, plus 3y cubed dy dx equals 0. All right, then look what would have happened. I would have taken this over here, which would have gave me a negative 3x squared y, which I have here. I would have taken a dy dx out, and I would have got 2 plus 3y cubed and divided by that, and I get there. So either way gives you the answer. All right, you can either do it at the end or the beginning. Some people, and I actually prefer, I just forgot to do it, I prefer to get rid of it up here so they don't have to worry about it at the end. All right, last one. All right, so let's go ahead and try this one. All right, now notice, what should we do with this first to find the derivative of this? Anytime you have a natural log and then you have a bunch of complicated stuff in here, make it easier by expanding it first. It's going to make your life so much easier. So this is actually 2 natural log of x plus the natural log of y equals 2x minus 3y. All right, it's easier to expand first. Now just take the derivative of all of these things. All right, if I just take the derivative, all right, all right, if I take, that's a bad color, sorry. All right, so if I take the derivative of this, all right, it's 2 times 1 over x plus 1 over y dy dx, y dy dx because it's a y, all right, equals 2, derivative of 2x is 2, minus 3y is 3, but a dy dx. All right, now let's get rid of the fractions here first. All right, let's not wait to the end. So if I multiply everything by xy, why did I pick xy? Because that's x and y here. Now when I multiply it through, the x cancels, leaving me with 2y, plus the y's cancel there, leaving me with x dy dx equals 2xy minus 3xy dy dx, right? So now I'm going to take my things that have a dy dx, which is this, move them to one side, whatever doesn't on the other, all right? So I'm going to move the things with dyx on the left side, and I'm going to take out a dy dx, right? Now you could just, since I'm doing on the mouse, it's harder. I don't feel like rewriting everything. So I'm going to skip a step and take out the dy dx. It's going to be x plus, because you would have to bring this over, so the negative now becomes a positive, 3xy equals 2xy. This is already on that side, minus, so I have to bring it over, minus 2y. And then divide by all of this. So my final answer is 2xy minus 2y over x plus 3xy. That's my derivative. All right, so that's implicit. We've done this before. It just so happens that we are doing it with natural logs. All right. Now, there's this other couple things that that are on this that we could do. It's on, I think relative extreme is on your homework sheet. We are not going to do it. All right. So you're just going to finish up some of the problems from that other worksheet for your assignment today. And then we will be moving on to integrals that involve natural logs. So we're just going to work in backwards. All right. Hope everyone's doing well. Stay safe. And I'll talk to you guys soon.